Here are some the limit problems. Let's try the first one. Limit of x approaches to 1, x minus 1 by x squared plus 2x minus 3. So the first step I would suggest you try plugging in. If I plug in the numerator, it gets 0. In the denominator, 1 plus 2 minus 3 is 0. So that really is not the right way of writing a number. So we're going to try a different way. Limit x approaches to 1. I'm going to first check, can I factor the denominator? The factors of denominator would be x plus 3, x minus 1. So x squared, 3x minus x is 2x, and 3 times negative 1 is negative 3. So this limit does work. Now x is approaching to 1, so x minus 1 is really not 0. It's close to 0. So we can divide both of them. So what we left with is limit x approaches to 1, 1 by x plus 3. Now you can just try to plug in 1 and it will work. 1 plus 3. The answer is 1 by 4. So this limit exists and is equal to 1 by 4. Let's try part B. Limit x approaches to 1, root x minus 1 by x minus 1. This is a problem with radical. Once again, if you try just plugging in 1, it'll gonna be 0 by 0, which does not exist. So first I'm gonna try to rationalize this radical function. So how you rationalize it, you're gonna come up with another expression and multiply and divide by it. So if you notice, it's the same expression in the numerator, but just change the sign. Okay. Now you should remember a formula from algebra. A minus b times a plus b is a square minus b square. So this is a, this is b, this is a minus b, and this is a plus b. So when you multiply them, that's going to be a square, which is root x square is just x, minus b square, which is 1 square, is just 1. In the denominator, we have x minus 1 times root x plus 1. Now we have x approaching to 1. We can cancel this factor. That will be root x plus 1. Limit x approaches to 1. If we can plug in 1 right now, it would be 1 plus 1. The answer is 1 by 2 for the limit. Limit x approaches to 3, x minus 3, x square minus 9. Again, if I put 3 straight, it's going to be 0 by 0. Doesn't work. So I need to factor the denominator somehow. And if you notice, that's in the form of a square minus b square, because this is basically 3 square. So x square minus 3 square can be written as x minus 3 times x plus 3 using our formula of factorization. We can divide by x minus 3 numerator and denominator because x is approaching to 3. Limit x approaches to 3, 1 by x plus 3. 1 by 3 plus 3 is 1 by 6. Limit x approaches to pi over 4. Sine of x minus cosine of x divided by tangent x minus 1. If I try to plug in pi by 4, the numerator is sine pi by 4 minus cosine pi by 4. Both are same, that would be 0. Tangent pi by 4 is 1 minus 1, that will be 0. It will become 0 by 0, which is not a defined number. So we can't do that. So I'm going to try to simplify this trig fraction by using some identities. Sine x minus cosine x divided by, tangent can be written as sine x by cosine x minus 1. Limit x approaches to pi by 4. Numerator, we have sine x minus cosine x. I'm not touching it. The denominator, we need to subtract these two fractions. I need to have common denominator, which is cosine x. To make this cosine 1 cosine x, I'll have to multiply it by cosine. So this will become sin x minus cosine x. Sin x minus cosine x divided by sin x minus cosine x. This fraction will flip, this cosine will come in the numerator. We know this will divide each other. What are we left with? Limit x approaches to pi by 4 cosine x. You can plug the value now. Cosine pi by 4 is root 2 by 2. So sometimes the limit directly substituting doesn't work. As you saw, in each of them doesn't work directly substituting. So either you can factorize and cancel, rationalize and cancel, factorize, simplify.